Hello everyone, welcome to the lecture on discrete mathematical structures. In my previous lecture video, we discussed about the principle of inclusion and exclusion and problems based on the principle of inclusion and exclusion. In this lecture video, we'll be discussing about the derangements and problems based on the derangements. So first we will define what is derangements. A permutation of n distinct objects in which none of the objects in its natural place will be called as an derangement. For example, I'll be taking a number 1, 2, 3, 4 and I'm fixing this as a natural number, that is 1, 2, 3, 4. So now I'll be rewriting this 1, 2, 3, 4 as 2, 1, 3, 4, 3, 1, 2, 4, 4, 1, 2, 3. And I'll be calling these three arrangements as a derangements. Why means we can observe that here none of the number in its natural place when compared with 1, 2, 3, 4. So similarly we can find the derangement for any number of numbers and in this table contains the derangement for 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3, 1, 4, 3, 2 like this. The formula to find derangement, it is given by the formula dn is equal to n factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial and so on minus 1 power n by n factorial for n is greater than or equal to 1. So we can simplify the formula as dn is equal to n factorial into summation k from 0 to n minus 1 power k by k factorial. For example, I want to find the value of d2. So to find d2, I'll be replacing n is equal to 2 in the above formula. I'll be getting 2 factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial. On simplifying this, you'll be getting the value is equal to 1. Similarly, we can find d3 also. To find d3, I'll be replacing n is equal to 3 in the above formula. I'll be getting 3 factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. On simplifying this, you'll be getting the value is equal to 2. Problems on derangement, evaluate d5, d6, d7, d8. So to find this, we'll be replacing n is equal to 5, n is equal to 6, n is equal to 7, n is equal to 8. Okay, if I replace n is equal to 5, I'll be getting d5 is equal to 5 factorial, 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. So it will be equal to what? 120 into 1 by 2 minus 1 by 6 plus 1 by 24 minus 1 by 120. On simplifying this, we will be having the solution 44. Similarly, d6, by replacing n is equal to 6, we will be getting 6 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial plus 1 by 6 factorial. It will be equal to 720 into 1 by 2 minus 1 by 6 plus 1 by 24 minus 1 by 120 minus 1 by 720. On simplifying this, we will be getting 256. Similarly, we can find d7, d8 by replacing n is equal to 7 and 8. So d7 is approximately equal to 1854, d8 is approximately equal to 14833. One more example, in how many ways can the integers 1, 2, 3 till 10 can be put in the order, that is no even integer in its natural place. So to find this, the first thing is what? We have to define the finite set S. So the S contains 10 numbers here, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore the order of S will be equal to 10 factorial. So now I will be defining the events A1, A2, A3, A4, A5 also. The event A1 assumes that the even number 2 in its natural place. The event A2 assumes that the even number 4 in its natural place. The event A3 assumes that the even number 6 in its natural place. The event A4 assumes that the even number 8 in its natural place. The event A5 assumes that the even number 10 in its natural place. So now the number of permutations where no even integers in its natural place is given by the formula order of A1 complement intersection A2 complement intersection A3 complement intersection A4 complement intersection A5 complement. It is given by order of S minus S1 plus S2 minus S3 plus S4 minus S5. So now we have to compute all this S1, S2, S3, S4, S5. So to compute the value of S1, we have to compute summation order of AI, right? So order of AI means it contains A1, order of A1, order of A2, order of A3, order of A4, order of A5. So now I am going to assume that the event A1 of the form B1, B3, B4 till B10. So and it is given by actual numbers 1, 3, 4, 5, 10 except the even number 2 here. So it means that the order of A1 is given by 9 factorial. Similarly, the order of A2, order of A3, order of A4, order of A5 we can compute it as 9 factorial only. So therefore what we can conclude now, the value of S1 is given by summation order of AI. It will be equal to 5 into 9 factorial. Then the value will be equal to combination of 5 comma 1 into 9 factorial. So now I am going to take the sequence for A1 intersection A2. So in A1 intersection A2, it is given of the form B1, 2, B3, 4, B5, B6, B7, B8, B9, B10. So where this B1, B3, B5, B6 till B10 is given by with the numbers 1, 3, 5, 6, 10 except the numbers 2 and 4 here. So hence we can take the order of A1 intersection A2 is 8 factorial. So similarly the order of AI intersection AJ will be equal to 8 factorial only, and they are in combination of 10 comma 2 in numbers. Therefore the value of S2 is given by combination of 5 comma 2 into 8 factorial. So likewise the value of S3 is combination of 5 comma 3 into 7 factorial. S4 is the combination of 5 comma 4 into 6 factorial. S5 is the combination of 5 comma 5 into 5 factorial. So now I'll be incorporating all these values in the previous formula. I'll be getting the value is 2170,680 after simplification. Problem number 3. From the set of all permutation of n distinct object, no permutation is chosen at a random. What is the probability that it is not a derangement? So actually the derangement is given by Dn. For n distinct object will be having n factorial as a permutation, right? So therefore the probability of the permutation chosen is not a derangement is given by P is equal to 1 minus Dn by n factorial. So 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial and so on minus 1 power n by n factorial we can write it. After simplifying this, we will be having the value of P is equal to 1 minus 1 by 2 factorial minus 1 by 3 factorial and so on minus 1 power n by n factorial is the required solution. Thank you.